Hello students, in this video we will be seeing solutions for previous year JEE question papers. So we will be focusing on the topic called general physics. So let us now see the first question. Using screw gauge of pitch 0.1 centimeter and 50 divisions on its circular scale, the thickness of an object is measured. It should be correctly recorded as. So we all know that the thickness is generally measured in a screw gauge. Thickness is generally measured you will be having the pitch scale reading plus HSE into least count. Okay, so HSE is the head scale coincidence and least count you have to multiply to it. So you will be getting the total reading, or here they have mentioned as a thickness. So thickness equal to pitch scale reading plus HSE into least count. So here you can easily calculate the least count by least count is equal to here they have given you the pitch as 0.1 centimeters and 50 divisions. So 0.1 divided by 50. So you will be having it as 0.002 centimeters per division. Okay, so 2 centimeter per division. So if you see here, it should be correctly here the integral is of 2 is answer number B only. 2.124 is only the integral of 2. Other things are all like odd numbers, only the even number here is 2.124. And since your least count is in 0.002 centimeter per divisions, the final answer will be an integral of this even number only. So the correct answer is option number B, 2.124 centimeters. Okay, so it's a very simple question. Just you are making use of the logic of the least count. So first you have to find out what is the least count is. It is 0.1 divided by 50, which is equal to 0.002 centimeters. And if you see the least count is 0.002 means the answer will be coming in the integral of an even number. So that's why you are choosing 2.124 as the correct answer. Other all are like odd numbers. Okay, so let us now move on to the next question. Two forces P and Q of magnitude 2F and 3F respectively are at an angle theta with each other. If the force Q is doubled, the resultant also gets doubled. Then the angle theta is. So here in the first case, R square is equal to 2F square plus 3F square plus 2 into 2F 3F cos theta. Okay. So when you solve this, you will be having R square is equal to 13F square plus 12F square cos theta. Okay. Now this is the first case. Now in second case, if you see, it is doubled. So the force Q is doubled. So you will be having it as 2R square is equal to 2F square plus 6F square plus 2 into 6F square cos theta. Okay. So if you solve this, you will be getting it as 4R square is equal to 40F square plus 24F square cos theta. Okay. So when you solve these two equations, you will be getting the theta value as theta is equal to 120 degree. Okay. So just you are going to solve these two equations, and when you try to solve this, you will be getting the theta value as 120 degrees. So it's just a mathematical solution. You are just going to solve it, and finally you will be getting the cos theta value equal to some value, and you take the cos inverse of that, you will be getting the theta value as 120 degrees. Okay, let us now move on to the next question. Two vectors A and B have equal magnitudes. The magnitude of A plus B is n times the magnitude of A minus B. The angle between A and B is. So similarly here you have to equate both the things, both the vectors. So it is equal to root of a square plus b square plus 2ab cos theta is equal to n times root of a square plus b square minus 2ab cos theta. Okay. So here they are given you b is equal to a or a is equal to b. So when a is equal to b, what will happen? This will become like a square plus 2a square cos theta is equal to n into root of a square plus a square minus 2a square cos theta. Okay. So now you can solve this. When you try to solve this, you take this a square as common, and this will become root of 2 plus 2 cos theta is equal to n into root of you will be having 2 minus 2 cos theta. Okay. So you take the square on both the sides, you will be having it as 2 plus 2 cos theta is equal to n square 2 minus 2 cos theta, or you can take this 2 as common, you will be having it as 1 plus cos theta is equal to n square 1 minus cos theta. Okay. So when you try to solve this, you will be getting the theta value as cos inverse n square minus 1 divided by n square plus 1. Okay. So the theta value, the angle between a and b will be cos inverse n square minus 1 by n square plus 1. So the correct answer is option number C. Okay. Let us now move on with the next question. Let a1 is equal to 3, a2 is equal to 5 and a1 plus a2 equal to 5. The value of 2a1 plus 3a2, 3a1 minus 2a2 is how much? Okay. So first what we have to do is we have to find out what is the value of cos theta. So you have to put a1 plus a2 is equal to 5. So 5 is equal to root of a square, a1 square 3 square plus a2 square 5 square plus a into b, sorry, a1 into a2 into 5 cos theta. Okay. So when you solve this, this is 5. Okay. So when you solve this, you will be getting the cos theta value as minus 3 by 10. Now they want us to find out what is the value of a1 plus 3a2 into 3a1 minus 2a2. So if you solve this, you will be getting it as 6 a1 square minus 6 a2 square plus 5 a1 into a2. Okay. So this is 6 a1 square minus 6 a2 square plus 5 a1 a2 cos theta. Okay. Because a1 into a2 is a modulus of a1 into a2 into cos theta, that is what you are getting. So when you solve this, 6 a1 square is 9. So 6 into 9 minus 6 into 25. Okay, because a2 is 5, so square is 25 plus 5 into 3 into 5 into minus 3 by 10. Okay, because cos theta is minus 3 by 10. So when you solve this, you will be getting it as minus 118.5. Okay, so the correct answer is option number D. So the value of 2a1 plus 3a2 into 3a1 minus 2a2 is minus 118.5. Okay, let us now move on to the next problem. The least count of the main scale of a screw gauge is 1 mm. The minimum number of divisions on its circular scale required to measure 5 micrometer diameter of a wire is. So generally in a screw gauge, the least count is given by, the least count is measure of one main scale division divided by the number of divisions on circular scale. Okay, so the number of divisions on circular scale. So here the minimum value to be measured per least count is 5 micrometer. So according to the given values, you have to find out what is the number of divisions is. So here they have given you the least count as 5 into 10 power minus 6. Okay, so 5 into 10 power minus 6 is equal to, here the main scale is 1 mm. So 1 into 10 power minus 3 divided by n, or n is equal to 1 by 5 into 10 power 3. Okay, or n is equal to 200 divisions. Okay, it's just a simple substitution of the formula where you are using the least count as least count is given by measure of one main scale division by the number of divisions on the circular scale, and here they have given you the minimum number of divisions on its circular scale is 5 micrometer. So 5 into 10 power minus 6 is equal to 1 into 10 power minus 3 by n. So n is equal to 200 divisions. So the correct answer is option number B, 200 divisions. Okay, let us now move on to the next question. The diameter and height of a cylinder are measured by a meter scale to be 12.6 plus or minus 0.1 centimeter and 34.2 plus or minus 0.1 centimeter respectively. What will be the value of its volume in appropriate significant figures? So volume of a cylinder of radius r and height h is given by, volume is given by pi r square h, or V is equal to 1 by 4 pi d square h. Okay, this is diameter, d square h. So where d is the diameter of the circular surface, and here they are given you the diameter as d is equal to 12.6. Okay, that's what they have given you, and height is 34.2. So it is 12.6 centimeters and 34.2 centimeters. So the volume will be pi by 4 into 12.6 the whole square into 34.2. So when you try to solve this, you will be getting the V value volume as 4262.22 centimeter cube, or you can write it in the significant number will be around approximately 4260. Okay, so this is in 3 significant numbers you are writing. So 4260. Now you have to calculate the error. So del V by V is equal to 2 times del D by D plus del H by H. So del V is equal to 2 into, here you are having it as 0.1. So 0.1 divided by 12.6 plus del H is again 0.1 divided by 34.2. So when you solve this, you will be getting the del V value as 79.7, which is approximately equal to 80 centimeter cube. So the V value will be 4260 plus or minus 80 centimeter cube. Okay, so this is the volume of the in appropriate figures, in appropriate significant figures, the volume will be 4260 plus or minus 80 centimeter cube. So the correct answer is option number B. Okay, so let us now move on to the next question. In the density measurement of a cube, the mass and edge length are measured as 10 plus or minus 0.10 kg and 0.10 plus or minus 0.001 meter respectively. The error in the measurement of density is, so here the mass is equal to 10 plus or minus 0.10 kg and the edge length is 0.10 plus or minus 0.01 meter. So the error in mass is given by error in mass. Okay, the error in mass is given by del m by m is equal to 0.1 by 10 and error in length del L by L is equal to 0.01 by 0.1. Okay, so the density of the cube is given by, density is mass by volume, so which is equal to mass by L cube, volume is L cube. Okay, so here the permissible error in density is given by del rho by rho is equal to del m by m plus or minus 3 del L by L. So you are going to substitute the values here. So del m by m is 0.1 by 10. So del rho by rho is equal to 0.1 by 10 plus or minus 3 into 0.01 by 0.1. So when you solve this, you will be getting the del rho by rho value as 0.31. Okay, so the correct answer is option number D. So first what we are going to do is, you are going to find out what is the error in mass and what is the error in length, and then you are going to find out what will be the error in measurement of the density. Okay, so it should be a generally del rho by rho will be a unitless quantity, so it will be 0.31. Okay. Okay, let us now move on to the next question. The area of a square is 5.29 centimeter square. The area of 7 such squares taking into account the significant figure is. So area of the square is given by, area of one square is given by, area of one square is equal to 5.29 centimeter squares. So area of 7 such squares is 7 times the addition of area of one square. Okay, so it is 7 into 5.29, so you will be getting it as 37.03 centimeter squares. Okay, as we know that if it is measured values to be added or subtracted, the least number of the significant digits after the decimal is n. Okay, so then in the sum of difference also the number of significant digits after the decimal should be n. So here the number of digits after decimal in 5.29 is 2. So our answer should also contain only 2 digits after the decimal point. Okay, so you are having the area required as 37.03 centimeter squares. So the correct answer is option number C. Okay, since here you can see the number of digits after decimal is 2, 5.29 means 29 is only coming, so 2 decimals. So our answer also should be in the range of only, it should contain only 2 digits after the decimal point. So here you can see in option number A we are having 3 decimals, option number B 1 decimal, and option number D no decimals. Only option number C is having 2 decimals. Okay, so the correct answer is option number C. Okay, let us now move on to the next question. In the form of G, universal gravitational constant, Planck's constant, and speed of light, the time period will be proportional to. Okay, so here let T is equal to, K G A H B and C C. Okay, where K is a dimensionless constant. For calculating the values of A, B and C, compare the dimensional formula for both the sides. So first we will do it for left hand side. You will be having time. So the dimensional formula is M0, L0 and T1. Okay, now we will go for the RHS. First you will find out what is G is. G is equal to F dot R square by M1 M2. Okay, so it is kilogram meter per second square into meter square divided by kilogram square. So you will be having it as M minus L cube T power minus 2 per A. Similarly, for H, you will be having H is equal to M1 L square T power minus 1 B. And similarly for C, you will be having M0 L1 T minus 1 C. Okay. So now you compare both the sides for powers of ML, L and T. Okay, so you can write the equations. In LHS you are having M0 L0 T1. Okay, and in RHS you will be having K into M minus 1 L cube T minus 2A and M1 L square T minus 1 B and M0 L T minus 1 C. So this will be on the RHS. Now if you compare both the sides for the powers, M will be equivalent to 0. So M is equivalent to 0 means 0 is equal to, here you are having minus A plus B, or A will be equivalent to B. Similarly, you compare this L again will be 0 is equal to, we are comparing the powers. So here you will be having 3A plus 2B and plus C. Okay, and similarly T is equal to 1, which is equal to, because T is 1 here, equal to minus 2A minus B minus C. Okay, so when you solve this, you will be getting the A and B and C values. So A will be half, B will be half, B will be half and C will be minus 5 by 2. Okay, so putting all these values in the equation, you will be getting T is equal to, in this equation number 1, if you just put this, you will be getting it as T is equal to K into G power half, because A is half, and H power half because B is also half, and c power minus 5 by 2. Okay. So, when you solve this, you will be getting t is directly proportional to square root of g h by c power 5. Okay. So, the correct answer is option number A, because they want to find out what is proportional. So, you are removing the constant and you are writing the proportionality. So, g, h and c is having square root as common, and the c is going to the denominator. It will become root of gh by c5. Okay. So, the time period is directly proportional to square root of gh by c power 5. So, what we are doing is here you are using this equation t is equal to k into GHC, and first thing what you are doing is you are calculating the values of A and B and C by comparing the dimensional formula on both the sides. So, you are writing the dimensional formulas and then you are finding out what is the A value, B value and C value, and you are comparing it. Okay. So, when you compare it, you will be getting all the three values and then you are substituting it, and then you are finding out to which value the time period is directly proportional to. Okay. Let us now move on to the next question. The density of a material in SI units is 128 kilogram per meter cube. In certain units in which the unit of length is 25 centimeter and the unit of mass is 50 grams, the numerical value of density of the material is. So, to convert a measured value from one system to another system, we will be using N1 U1 is equal to N2 U2. So, where N is the numerical value and U is the unit. So, here again we are converting. Okay. So, you will be writing it as 128 into the unit is kilogram per meter cube is equal to N2 into 50 gram. So, the unit mass is 50 grams. So, 50 G by 25 centimeter cube. Okay, because density is mass by volume. So, if you solve this, you will be getting it as 128 into 1000 gram divided by 100 into 100 into 100 centimeter cube, which is equal to N2 into 50 gram divided by 25 into 25. Okay, this is 25 centimeter cube, the whole cube. Okay, 25 into 25 into 25 centimeter cube. So, you will be taking N2 this side, you will be having 128 into 1000 into 25 into 25 into 25 divided by 50 into 100, 50 into 100 into 100 into 100. So, when you solve this, you will be getting the N2 value as 40. Okay, just a mathematical solution, just solving it, cancelling the common terms, and if you solve this, you will be getting the N2 value as 40. So, the numerical value of density of the material is 40. So, the correct answer is option number A. Okay. Let us now move on to the next question. The force of interaction between two atoms is given by F is equal to alpha beta exponential minus x square by alpha kt, where x is the distance and k is the Boltzmann constant and T is the temperature, and alpha and beta are two constants. The dimension of beta is. So, here the force of interaction between the two atoms is given by F is equal to alpha beta, that is what they have given you, exponential minus x square by alpha kt. Okay. As we know, the exponential terms are always dimensionless. So, the dimensions of minus x square by alpha kt is equal to m0, L0 and T0. Okay, so the dimensions of alpha is equal to the dimensions of x square by kt. So now we are substituting the dimensions of the individual terms in the given equation. We will be getting it as m0 L square T0 divided by m1 L square T minus 2. Okay. So first thing is you are writing the force equation what given, alpha beta exponential minus x square by alpha kt, and we know that the exponential terms are always dimensionless. So the dimensions of minus x square by alpha kt will be equal to m0 L0 and T0, and dimensions of alpha will be equivalent to the dimensions of x square by kt. Okay. So you are substituting the dimensions of the individual terms in the given equation. We will be getting it as m0 L square T naught by m1 L square T power minus 2. So the dimensions of kt equivalent to the dimensions of energy is equal to m L square T power minus 2. So if you solve this, you will be getting it as m minus 1 L0 T square. Okay. So now from the given equation we have dimensions of dimensions of f is equal to dimensions of alpha into dimensions of beta, or dimensions of beta is equal to, okay, because f is equal to, that is dimensions of f is equal to dimensions of alpha plus into dimensions of beta. Okay. So this is multiplication. So you will be having the dimensions of beta is equal to dimensions of f by alpha. Okay. So the dimensions of f is given as f is equal to m1 L1 T power minus 2 divided by m minus 1 L0 T square. So this will be m square L1 T power minus 4. Okay. So the correct answer is option number C, m square L T power minus 4. So the dimensions of beta will be m square L T power minus 4. Okay. Let us now move on to the next question. If speed, acceleration and force are considered as fundamental units, the dimensions of Young's modulus is. So here first you write down what is the dimensions of speed are. So the dimensions of speed are, speed is, first you write down the dimensions of speed, v is equal to L t minus 1, and next you write down the dimensions of acceleration, acceleration is equal to L t minus 2, and next you write down the dimensions of force, F is equal to m L t minus 2. Okay. So the dimensions of Young's modulus is y is equal to m L minus 1 t power minus 2. So they want the dimensions of Young's modulus in terms of speed, acceleration and force. Okay. So let the dimensions of Young's modulus expressed in terms of speed, acceleration and force, y is equal to v power alpha, a power beta and f power gamma. Okay. So v is the speed, a is the acceleration and f is the force. So now you substitute the dimensions inside, you will be having m L minus 1 t power minus 2, that is for Young's modulus, and v is L t minus 1 alpha and a is L t minus 2 beta and f is m L t minus 2 gamma. Okay. So now you compare these things. First we will do it for m. So m is 0. So here it is 1. Okay, m is 1. So 1 is equal to, here it is 0, 0, and here it is m is 1. Okay, so gamma will be equal to 1. So we have found the gamma value. Next you equate for L. So L will be minus 1 is equal to, here you are having alpha plus beta plus gamma. Since gamma is 1, you will be having alpha plus beta is equal to, here it is 1, so it goes to that side, it will become minus 2. Next we equate for t. So t is here minus 2 is equal to minus alpha minus 2 beta and minus 2 gamma. Okay, so which is equal to 2 and gamma is equal to 1. So this minus 2 and minus 2 will get cancelled with each other, and you will be having alpha is equal to 2 beta. So if alpha is equal to 2 beta means your beta will go here and it will become 2 alpha. Okay, so minus 2 and minus 2 will get cancelled with each other, and alpha will be equivalent to 2 beta. So when you solve this, you will be getting alpha is equal to minus 4 and beta is equal to 2 and sorry, it's minus 2, not plus 2, it's minus 2, and beta is equal to 2 and gamma is equal to 1. Okay, so if you see this, you have to substitute the values over here. So y will be equal to v, alpha is minus 4 and beta is 2 and gamma is 1. So in terms of speed, acceleration and force, the dimension of Young's modulus is v power minus 4 a square f. So the correct answer is option number D. Okay, let us now move on to the next question. Let L, R, C and V represent the inductance, resistance, capacitance and voltage respectively. The dimensions of 1 by R CV is. So first you write down what is the dimensions of inductance, resistance, capacitance and voltage. So we know that the inductance resistance is L is equal to M L square T power minus 2 A power minus 2. Similarly, the resistance dimension is M1 L square T power minus 3 A power minus 2. Similarly, the capacitance C is equal to M power minus 1 L square T power 4 A square, and for voltage it is M 1 L square T power minus 3 A power minus 1. Okay. So here you want the dimensions of L by RCV. It is L by RCV is equal to, here you are having L is M1 L square T power minus 2 A power minus 2 divided by RCV is. So M and M will get cancelled, you will be having M here, and next L square L square L square. Okay, so L square and L square you will be having it as L square and T power minus 2 and A power minus 1. So M 1 L square T power minus 2 and A power minus 1. So when you solve this, you will be getting it as okay, here it is T power minus 2. Okay, so 2 into this 2 will get cancelled and you will be having on L square, and here you are having minus 3 plus 4 and minus 3. So, it is minus 6 plus 4, it will be minus 2. Okay, and here it is minus 2 and plus 2, they will cancel with each other and you will be having a power minus 1. So, when you solve this, you know m and m will get cancelled, L square will get cancelled, t power minus 2 and t power minus 2 will get cancelled, and when it is go to the numerator, L by R CV will be equal to a power minus 1. So, the dimensions of L by R CV is a power minus 1. So, the correct answer is option number C. Okay, it is a very simple problem, just you are going to make use of the dimension values. First you are writing on the dimension of inductance, resistance, capacitance and voltage, and then you are finding out what is the ratio between L by R CV, which is equal to a power minus 1. Okay, let us now move on to the next question. In SI units, the dimensions of epsilon naught by mu naught is. So, generally the dimensions of permittivity of free space is given by permittivity of free space is m power minus 1, L power minus 3, t power 4 and a square, where c is the speed of light. So, the dimension of c is L t minus 1. So, what happens is the dimensions of root of epsilon naught by mu naught will be equal to root of epsilon naught square by epsilon naught mu naught. You are multiplying epsilon naught on numerator and denominator. Why we are doing this is because we know that c square is equal to 1 by root of mu naught and epsilon naught. So, here you are having 1 by root of epsilon naught and mu naught, the square root. Okay, so that will be c, and epsilon naught square, when you take it out of the square root, it will become epsilon naught c. So, you will be getting it as epsilon naught c. So, in order to simplify it, we are doing this, and you know what is the epsilon naught values: m power minus 1, L power minus 3, t power 4 and a square. This is the dimension for epsilon naught, and c dimension is L into t power minus 1. So, when you solve this, you will be getting the dimensions for epsilon naught and root of epsilon naught by mu naught as m minus 1, L power minus 2 and t power 3 a square. Okay, so this is the dimensions of root of epsilon naught by mu naught: m power minus 1, L power minus 2, t power 3 and a square. Okay, so the correct answer is option number D. Okay, let us now move on with the next question. If surface tension S, moment of inertia I and Planck's constant h were to be taken as the fundamental units, the dimensional formula for linear momentum would be. Okay. So, here they want us to find out what is the formula, like what will be the dimensional formula for linear momentum. So, let P is directly proportional to h power a. So, h is what? Planck's constant, into s power b, s is surface tension, and I power c, okay, where I is the inertia. So, P is equal to k into h power a, s power b and I power c. So, where k is a dimensionless proportionality constant. So, modulus of P is equal to h power a, s power b and I power c. Okay. So, the respective dimensions of the given physical quantities are first we write down what is the dimensions for P. So P is momentum, so mass into velocity. So the dimension constant for P will be, dimensions for P will be ml t power minus 1, and inertia I is given by I is mass into the distance square. So it will be ml square t0. So this is for inertia. And next is surface tension. You will be having it as force into length. So it will be mass ml0 t power minus 2. Okay. And the next one will be h. H is Planck's constant. So you will be having h is equal to ml square t power minus 1. Okay. So if you substitute these dimensions in equation 1, you will be getting here, over here if you substitute, you will be getting it as ml t minus 1 is equal to h is m l square t minus 1 per A, s is m t minus 2 per B, and m l square C. Okay. So in a similar way as we did in the previous problem, you are going to equate the m first. So you will be getting it as 1 is equal to A plus B plus C, because m term is there in all the three cases. So it will be A plus B plus C is equal to 1. So this is for m. Next you equate L. So L again here 1, here it is 2, 2A, and here you are having 2C. So 2 into A plus C is equal to 1, or A plus C will be equal to 1 by 2. A plus C is equal to 1 by 2. Next you equate T. You are having minus 1 minus A, minus A minus 2B is equal to minus 1. So when you solve this, you will be getting it as A plus 2B is equal to 1. So when you solve all these three equations, you will be getting the A value as 0, B value as half, and C value as half. So automatically if you substitute for momentum, P will be equal to h power 0, s power half, and I power half, or the momentum is s power half and I power half. So the correct answer is option number C. Okay, where s power half and I power half and h power 0. Okay, so the correct answer is option number C. So it's a very simple problem. Just they have asked us what will be the momentum, like dimensional formula for the linear momentum in terms of surface tension, moment of inertia, and Planck's constant. So first you are writing down dimensions for momentum, and then for surface tension, moment of inertia, and Planck's constant, and then you are equating and finding out what will be the values of A and B and C, and then you are substituting in this equation. Okay, so that you will be getting the relation of momentum in terms of surface tension, inertia, and Planck's constant. Okay, let us now move on to the next question. The pitch and the number of divisions on the circular scale for a given screw gauge are 0.5 millimeter and 100 respectively. When the screw gauge is fully tightened without any object, the zero of its circular scale lies 3 divisions below the reference line. The readings of the main scale and the circular scale for a thin sheet are 5.5 mm and 48 respectively. The thickness of the sheet is. So here the least count is given by, least count is pitch by number of division, pitch by number of division. So least count is equal to, here the pitch is how much, they have given it as 0.5 mm and number of divisions is 100. So it is 0.5 divided by 100. So the least count will be 5 into 10 power minus 3 millimeter. Okay. So here you want to find out what is the thickness, and they have told you like the values around 5.5 mm and 48 respectively. Okay. So they have told that the main scale reading or the pitch scale reading is 5.55 and the head scale coincidence is 48. So as we saw in the first problem, thickness is given by pitch scale reading plus head scale coincidence into least count. So here the pitch scale reading is 5.5 plus here head scale is 48 into 5 into 10 power minus 3. Okay. So here 48 is there and you need to add a plus 3 to it. Okay. So it is 48 plus 3 into the least count. Okay. So if you solve this, you will be getting the answer as T is equal to 5.755 mm. Okay. Why we are adding this plus 3 is the zero error is 3 divisions. Okay. And it is a negative error because it is lying below the reference line. So that's why we are adding this 0 error to the head scale coincidence. So that plus 3 is being added and you will be getting the T value as 5.755 mm. Okay. So the correct answer is option number C. So first you are finding out what is the least count with the help of the pitch value and the number of divisions, and you are getting it as 5 into 10 power minus 3. And then you are finding out the total reading with the help of the pitch scale reading and head scale coincidence. And here head scale coincidence you are adding plus 3 because there is a error correction over here where 3 divisions lie below the reference line. So it is a negative error. So you are adding it to the final value. So 48 plus 3 into 5 into 10 power minus 3. So this is the least count. Okay. And you are getting the T value as 5.755 mm. Okay. Let us now move on to the next question. The density of a material in the shape of a cube is determined by measuring 3 sides of the cube and its mass. If the relative errors in the measuring the mass and length are respectively 1.5% and 1%, the maximum error in determining the density is. So here again they want us to find out what is the maximum error in determining the density. Okay. So here they are given that del m by m into 100. So this is for the mass. The relative errors for the mass is 1.5% and for length is del L by L into 100 is equal to 1%. Okay. So D is given by the density is mass by volume. So mass by L cube. So which is equal to del D by D into 100, which is equal to del M by M into 100 plus 3 del L by L into 100. Okay. So del M by M into 100 is 1.5 plus 3 into 1. So you will be getting the value as 4.5%. So the maximum error in determining the density will be 4.5%. So the correct answer is option number D, 4.5%. Okay, let us now move on to the next question. A screw gauge with a pitch of 0.5 mm and a circular scale with 50 divisions is used to measure the thickness of a thin sheet of aluminum. Before starting the measurement, it is found that when the two jaws of the screw gauge are brought in contact, the 45th division coincides with the main scale line and that the zero of the main scale is barely visible. what is the thickness of the sheet if the main scale reading is 0.5 mm and the 25th division coincides with the main scale line. Okay. So, here the least count is given by, the least count is pitch by number of divisions. Okay. So, it is pitch by number of divisions. So, here the pitch value is 0.5 by 50 mm. So, the least count will be 0.01 mm. Now, there is a negative error, okay, because it is brought 45 division coincides with the main scale. So, it is a negative 0 error. So, the negative 0 error will be 50 minus 45 into the least count. Okay. So, the negative 0 error is 50 minus 45. So, which is equal to 0.05 mm. So, here the measured value will be equal to main scale reading plus screw gauge reading plus the negative error. Okay. We know that. So, you will be having the total reading or the measured reading as main scale reading. Here the main scale reading is 0.5. So, 0.5 plus 25 into least count, 25 into least count 0.01 plus the 0 error 0.05. So, if you solve this, you will be getting the value as the total reading as 0.8 mm. Okay. So, the correct answer is option number B. So, the total reading or the measured reading will be 0.8 mm. So, it is a very simple problem. If you see all the screw gauge problems, they will give you the values of the pitch and the number of divisions. You should first find out what is the least count, and you can make use of the general formula. So, you can consider like this: total reading is equal to pitch scale reading plus HSE into least count. Okay. So, pitch scale reading is the pitch what measurement it is showing, and HSE is the head scale coincidence. Okay. So, here you need to add plus or minus the 0 error or the 0 correction. Okay. So, they will in some questions they will tell the screw gauge will be having some kind of a 0 error. That value, either if it is a positive error you have to subtract, and if it is a negative error you have to add with the head scale coincidence, so that you will get the correct value of the total reading. Okay. So, the correct answer here is option number B. Okay. Let us now move on to the next question. Let epsilon naught denote the dimensional formula of the permittivity of vacuum if m is equal to mass and L is equal to length, T is equal to time and A is equal to electric current. Then epsilon naught is equal to m power minus 1 L power minus 3 T power 2A, or epsilon naught equal to some other dimensions. Okay. So, from Coulomb's law we know that F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. So, epsilon naught will be equal to Q1 Q2 by 4 pi F R square. So, substituting the units, we have epsilon naught equal to C square by Nm square. So, we are substituting the units. So, for Q it is C and force into R square is Newton meter square. So, you are substituting that. Okay. So, now you write down the dimensions. You will be getting it as dimension of epsilon naught as C square is A T square divided by M L T power minus 2 into L square. So, when you solve this, you will be getting it as M minus 1 L power minus 3 T power 4 A square. Okay. So, the dimensions of epsilon naught is m power minus 1 L power minus 3 T power 4 and A square. So, the correct answer is option number B. Okay, let us now move on to the next question. A vernier calipers has 1 mm marks on the main scale. It has 20 equal divisions on the vernier scale which match with 16 main scale divisions. For the vernier calipers, the least count is. So again here the least count of vernier calipers is given by, the least count is given by 1 main scale divisions minus 1 vernier scale division. So or the smallest division on the main scale by the number of divisions on the vernier scale. So here the 20 divisions of vernier scale is equal to 16 divisions of main scale. So 1 vernier scale division is equal to 16 by 20 main scale division. So or if you solve this, you will be getting it as 0.8 mm. Okay, so this is 1 VSD. So the least count is 1 MSD minus 1 VSD. So 1 mm minus 0.8 mm. So if you solve this, you will be getting the least count as 0.2 mm. So the correct answer is option number D, 0.2 mm. Okay, so here the least count of the vernier calipers is given by 1 main scale division minus 1 vernier scale division. Okay, so or you can say it as smallest division on main scale by the number of divisions on the vernier scale. So here they have given 20 divisions of vernier scale is equal to 16 main scale divisions. Okay, so that's what you are substituting here. 1 VSD equal to 16 by 20 MSD, which is equal to 0.8, and you know what is 1 MSD is 1 and 1 VSD is 0.8. If you subtract that, you will be getting the least count as 0.2 mm. So the correct answer is option number D. Okay, let us now move on to the next question. The circular scale of a screw gauge has 50 divisions and pitch of 0.5 mm. Find the diameter of the sphere. Main scale reading is 2. Okay, so here the least count is pitch divided by number of divisions. That's what we are writing in all the problems, and here they are given you the pitch as 0.5 divided by 50. So you will be having it as 0.01 mm. So here they are saying there is a you can see you will be having a positive error, because here you can see it is around 25. So there is a positive error. So you have to subtract that because it is a positive error. So positive error is 5 into 0.01. Okay, so 5 into 0.01. Here you can see, the main scale reading is in 2 they have told, but here it is near 25. Okay, so the main scale reading is in 2 and the coincidence is in 25. So there is a kind of a positive error which should be finally subtracted. So you will be having the total reading as 2 into 0.5 plus 25 into 0.01 minus 0.05. So if you solve, you will be getting the total reading as 1.2 mm. So this is the positive error. So you are subtracting with the final value. So you will be getting it as 1.2 mm. So the correct answer is option number A. So the diameter of the ball is 1.2 mm. Okay, let us now move on to the next question. A cube has a side of length 1.2 into 10 power minus 2 meter. Calculate its volume. It's a very simple question. So here what we have to see is we have to check what are all the significant values we have. So we know that V is equal to L cube, or it is 1.2 into 10 power minus 2 the whole cube. Okay, so you will be getting it as 1.728 into 10 power minus 6 meter cube. Okay. So here length has two significant figures, volume should also have two significant figures. So therefore, we are going to, since they have given the length as 1.2, you have to take volume approximately equal to 1.7 into 10 power minus 6, because only two significant figures are there. So the correct answer is option number A. So if you see the other options, here it is 3 significant figures, here 4, and here again 3. Only option number A is having 2 significant figures. So the correct answer is option number A, 1.7 into 10 power minus 6. I think this video would have been useful for you to recall some of the problems from this particular topic called general physics. So some certain percentage of questions are coming from this particular unit, and it will be very simple only. If you understand the logic behind that, you can easily solve these questions. Thank you for watching this video, and all the best for your examinations.